in the question they have said that there is a car of mass m which is at rest, and it acquires a velocity v I cap around the east direction in 2 seconds. Now they are saying, as since there is the increase in the velocity from 0 to v, so they are assuming that the car performed a uniform acceleration in this time interval delta t of 2 seconds. So since they are asking us to find the force exerted on the car, we need to find the acceleration of the car, that is a bar. Okay, so we know that acceleration is defined by delta v bar by delta t, and we know that the v final bar minus v initial bar by delta t. We know that the v final is our v I cap, that is along east direction, minus initial velocity 0 by delta t is 2 seconds. So overall, when I say the acceleration of the car, it is actually v I cap by 2. So it is not as simple as you are thinking. It involves many conceptual understanding. It involves many concepts. So let us first understand what is happening. What are the forces exerted on the car tires? Okay. So since this is a car tire, so here what is happening over here is this whole body exerts its weight on the car tires. Means the whole weight of the car body of the car is exerted on these tires. So when I talk about the force acting on the tire is mg. Since this tire is not only contact from the it is not only contact with the body of the car, upward body of the car, it is also contacting with the ground. So it exerts the same amount of force which is exerted by it on from the car. So here the tire now here the tire is exerting force on the ground of amount mg. So since every action has a reaction, then the ground will also exert the same amount of force mg, but in the opposite direction. So here now when I talk the force acting on the tire by the ground, that is equals to normal force. This is normal force is a force acted by the ground on the tire. That normal force magnitude is also equals to mg. So when I talk about the car tire, I can say that the upward force and downward forces are equal. So the car tires are since the upward force and downward force cancel each other, the car tires are in vertical equilibrium. Now let us find due to which force this car is moving forward in this car is moving in the forward direction. To understand that, first let us understand what is happening over there. So we know that as there is an engine which runs on the petrol, when the petrol is poured in engine, this petrol undergoes combustion, and it releases some amount of energy. The energy which is released, it is used in spinning this axle which connects the two tires of the cars. Okay, so as this axle spins, so the tires since the tires of the cars are since the car tires are in contact with this are connected to this axle, so tires also start spinning along this axis. But the ground provides obstacle to them, because since the tires are in contact with the ground, the tires can't spin freely, so that the car tires exert some amount of force on the ground. Let it be f amount of force on the ground. Since every action has a reaction, then ground also exerts the same amount of force on the tires, that is in the opposite direction according to Newton's third law. Now the force acting on the tire is in the forward direction. Now because here this force was exerted by the tire on the ground. Now I am talking about the force acting on the car tire. Then it is the force exerted by the ground on the tire. It is in the forward direction. According to Newton's third law, both action and reaction forces are equal in magnitude but are opposite in direction. They won't cancel each other because the force acting are on the different bodies. Here, this force is acting on the ground, but this reaction force is acting on the tire. So they won't cancel each other. And we know that this force which is exerted on the tire, it is stopping the motion of the tires. It is stopping the tires from spinning, since the force which opposes the body from moving, then that force is called frictional force. So indirectly our reaction force which is acted on the tire, it is actually a frictional force. So this frictional force is exerted by the ground on the tire. So we can say that the frictional force F is equals to the magnitude of the frictional force is equals to the magnitude of the action force, and the magnitude of action force is equals to m into acceleration of the car. And we know that m is the mass of the car, then acceleration of the car we already found that mv by 2 I cap. So what we can derive the conclusion that there is the frictional force. The frictional force acting on the tire is responsible for this motion of the whole car in the forward direction. And what is the amount of the frictional force? That is equals to mv by 2, and the frictional force is acting in the eastward direction. So our option B is true. That is the force exerted on the car in the force exerted on the car is mv by 2 in the eastward direction, and is due to the friction on the tires exerted by the road. So our option B is